This is a really simple tutorial to show how to make a bicycle tire with tread. This is what we call a 622mm tire, 25 millimeters wide. The tread we are going to make is alternating on the left and right hand side of the tire. The tread profile is nothing more than a simple cross section which is going to be revolved around an axis. Added to the tire will be a little ridge that runs on the sidewalls. When we make one example of the tread, we will be patterning it on one side of the tire, mirroring it to the other side, and shifting everything so the tread alternates as you see here. The starter file consists of a rim layout sketch, which is not actually used in the creation of the tire, but helps define some of the shapes of the tire in this area that are needed in order for the tire to properly clinch onto the end of the rim. The next sketch is the actual cross section of the tire itself, and here we can see this detail which is clinching around the sketch for the wheel rim. When making your tire, you can actually have this rim layout hidden the entire time because you won't be needing it. Next sketch gives us the outer diameter of the tire and location where we want the sidewall ridge to be located. Other than that, there isn't too much information here. Finally, we have a sketch which is a tread sketch plane locator sketch. I guess that's a bit awkward. What this has is some pie sections angled at 3 degrees on either side of the horizontal that intersect with the outside of the tire. The 3 degrees comes from the idea that we're going to pattern the tread 60 times around the perimeter of the tire. So 360 divided by 60 is 6 degrees, so we have 3 degrees above and 3 degrees below. This wedge is going to define the maximum size we want to make our tread so that tread in one wedge doesn't overlap tread in another wedge when being patterned. We're just projecting these lines out and creating an area where we're going to have a sketch plane that we're actually going to draw our tread on. This dimension is arbitrary. It's only important that the sketch plane is somewhere out beyond the tire so that when we cut the tread in, it can be out here and do a cut in this direction. Going back to the example file, I've rolled back to the first feature. This is nothing more than copying the profile of the tire, and this is only one half of the tire, and having a construction line that coexists with the axis in the file. Then we're just going to take and do a revolve on that to get one half of the tire. The next step, step number 2, is to make a copy of the outside of the tire and then also offset it 1/4 millimeter. Draw 2 vertical lines spaced 3/4 millimeter apart. This line aligns with the layout sketch in the sidewall ridge layout. This profile then was just simply revolved around the center axis. Step 3 is to draw on the tread sketch plane whatever we want our tread to look like. What I've done is put in some horizontal lines have a coincident relation to these lines in this wedge sketch, which is the tread sketch locator. This gives me the extents that I want to draw, the shape of my tread. You can see that I'm using splines in here, and wherever splines come together, I'm just leaving them as a sharp point. So sharp points here, sharp corners here, no rounded corners. We'll add those later on. Now remember, what we're going to do is pattern this tread a spacing of 6 degrees, so this tread will get patterned up this way and down this way. And on this side of the tire, we're going to mirror the pattern over, but we're going to shift it so that the pattern alternates back and forth. So we won't know exactly what this pattern is going to look like until we're completely done. And normally what we would do is just take this pattern and do an extrude cut, this profile, and take an extrude cut into this surface. What I want to do is add some fillets wherever these sharp corners are, and whenever you add fillets to sketches, things can get kind of squirrely. So I'm going to do a little trick. I'm actually going to extrude this going in the opposite direction and just create some temporary blocks or tread bodies sitting out here in space. Now that I've established those, I can easily add fillets to edges wherever I want the sharpness removed. So here I've added, since these are two separate bodies, I can't add a fillet to this body at the same time I'm adding a fillet to this body. They have to be separate features. So here I'm just filleting the corners of these bodies so that we have a more realistic and finished looking tread that has all the corners rounded out. It's easier to do this after this extrusion is made, because then I don't have to worry about my splines freaking out in my sketches. Now that I've got these fillets, what this gives me is a face with the shape that I want here and here. And now what I can do is draw a sketch on these faces, copy these edges, and then do the actual cut into this surface. So that's what I'm going to do. What I've done is simply picked one of these faces as my sketch plane, started a new sketch, and all I have to do is click in the middle of the face and select Convert Entities in order to convert all the edges of that face. I'll just demonstrate here. So I'm going to click on this face, Convert Entities, and it searches for all the edges of that face. I'll click on this face, convert those entities, and it finds all the edges of that face. When I make my cut, I want it to be an offset from surface cut. So I'm going to go to this surface, select Offset from Surface, and I'm going to cut to a depth of about 0.4 millimeters. Just to confirm that I'm going into the surface and not away from the surface, I can toggle the reverse offset check mark and just see which way the cut is going. So that's not going quite to the surface, that's going into the surface. There's my one example of the tread. Now I don't need this anymore. So I'm going to go ahead. Before I do that, I could have done this in either order. I'm going to go ahead and pattern this tread. This is just 60 copies patterned about axis number 1. Now you might wonder, why didn't I just go ahead, if I was having so much trouble adding fillets to splines in the sketches, why didn't I just go ahead and make it cut directly and then go ahead and add my fillets to the corners after the cut? The reason for this is that Solidworks would have to calculate all of those fillets when it's making the circular pattern. That would be about 8 fillets times 60 copies, so about 480 fillets it would have to calculate. I did an experiment and found that the difference in time between doing it this way and doing it where we add these fillets separately and pattern those is the difference between 20 seconds and about 180 seconds. So you can see how this method is much faster by getting the entire profile into the cut all at once. The next step, and I probably should have done it before patterning, but it doesn't matter, is just get rid of these temporary blocks. Go to the Solid Bodies folder and identify which are the blocks we want to get rid of by just highlighting them here in the folder. So I'm going to right click. I can pre-select holding Control. I'll right click both of these. Sorry, left click while selecting them, then right click, and then go down to Delete Bodies. That gets rid of both bodies and places a feature in the feature tree. So we have everything we need in one half of the tire. So the other thing to do then, of course, is make the other half. This is simply mirroring the body over using the front plane. And we see that by doing this, the tread matches up on both sides. By the way, when we do this mirror, make sure that not only is merge solids, make sure that merge solids is unchecked, because we want to later on shift this side of the tire. Because merge is unchecked, we have the seam running down the middle temporarily. Now what we want to do is take this new half that we created and we're going to twist it so that everything shifts with respect to the original side of the tire. To do this, we're going to use Insert, Feature, Move Copy. We're going to use the Rotate option. Translate allows us to move things in the X, Y, and Z direction. Rotate lets us rotate a body about an axis. The body we're going to rotate is going to be the one we just copied. We're going to rotate it. So I'm highlighting the rotate box. We're going to rotate it about axis 1. And I'm going to shift this 1/2 of a pattern. Since these were patterned at 6 degrees, I'm going to shift this by 3 degrees to get the alternating pattern that I want. There we have it. So we have our tire, but it's still 2 separate halves that are joined at the seam, but they're not glued together. To glue them together, we're going to go to Insert, Feature, Combine. Some of you might have it up here already on your menu. Combine, and I'm going to make sure that Add is selected, and I'm going to add this part to this part. Now you see they're glued together and that seam is gone. The last step is to add a little color to this. Those tires are not a light blue color like this, so we'll go up to the top of the feature tree, right click on the name of the file, go to our appearances. We're going to change the entire color to something like a dark gray. We don't want to make it black. We won't be able to see any lines very easily. Then what we want to do is maybe change the sidewall color. And a lot of traditional tires have kind of like a buff color on the side. So I'm going to hold down my Control key. And I'm going to select this surface and this surface. Right click, go to Appearances again, and we're going to change just the color of those faces. And this gives me sort of a buff color, that sort of gum wall color, and do the same to the side here. holding down my control, left click here, and here, right click, change the color of the face, same color. Now you have something that looks a little bit more like a realistic tire. Tires come in all kinds of colors nowadays. You can change this to green. You can even change the tread color if you like. So experiment with that and experiment with the shape of your tread. So one of the ideas in this tutorial is you should be creating your own tread, not just duplicating this one. In addition to that, if you have a very slow computer, 60 copies of the tread might really bog things down for you. If you have to go down to 30 copies, then go back to this sketch here and change this angle as is appropriate. So if you're only going to do 30 copies, this should be 6 degrees and this should be 6 degrees. And when you do your shift on this side of the tire, now you're going to be shifting a full 6 degrees instead of 3 degrees in order to get the alternating pattern. So just play around with that and see what kind of different effects you can get.